Welcome back to my channel, students. So today we're going to be looking at another video on trigonometry. But this time, since we already touched on basics, you already were introduced to Pythagoras' theorem, we are going to be looking at trig ratios. I need to insert an echo button here. Oh well. So one of the most popular, iconic acronyms you would see popping up all over the news, I mean books, but you know what I mean, is the acronym that is called SOHCAHTOA. Now, I have not traveled the world myself, so I can't say if internationally all countries say it the same, but here in the Caribbean, I know that we usually say SOHCAHTOA or SOHCAHTOA if you want an accent. So what does this popular SOHCAHTOA really mean? Well, it's an acronym. I said that before. And you know, as with all good acronyms, they represent something that's longer, like a word or something, you know. So this is where, if you have never done it before, you'll be seeing sine, cos, and tan for the first time. So the letter S represents sine. So we're going to put sine of an angle. Let's just say theta, because you know the most popular angle is represented by theta. And the O, because you guys would have done the basics, sine theta is actually the ratio of two sides of a right angle triangle. And O represents your opposite side. And H, can you guess? Yep, that's correct. H represents our hypotenuse. Now let's give it a go with Ka. So Ka, well, another trig function we have is cos theta, and that's actually the ratio of two different sides of your triangle. Can you guess what A represents? Yep, A represents the adjacent, the one and only. And H, well, there's pretty much only one H in the triangle. That's the hypotenuse. And then lastly, we have the toe. Well, toa. And T represents tan theta. And tan theta is also a ratio of two sides of your right angle triangle. And O, from our first ratio, you can tell O represents the opposite and A represents your adjacent. And there you have it, the acronym SOHCAHTOA. Now you finally know what each of them mean. Now you're probably asking yourself, that's great. So how is this helpful in my life? Well, keep watching. So I'm going to pop a question on screen. Pop meaning draw. That's right. Old school way. So I'm going to draw a triangle here. I get a nice little triangle here on screen. And we have a right angle triangle on screen there. And I'm going to put theta all the way at the bottom there. And by now you guys should be acing, naming your sides. This is your hypotenuse. This is your adjacent. And this is your opposite. Okay, all right, cool. Now, what if instead of using Pythagoras' theorem, the question said to find the length of a certain side? Well, is there another way you can do so? Yes, you can actually use SOHCAHTOA to find the length of a missing side. But using SOHCAHTOA when you have 2 out of 3 sides is usually not the best option because Pythagoras' theorem can be way faster. So when exactly do people use SOHCAHTOA if not to find sides all the time? Well, do you notice that each of these trigonometric ratios has a theta involved? And so far, we've been dealing with the perimeter of our triangle, that outside portion there. We have not gotten to the inside of our triangle, have we? And the inside of our triangle has angles, man. We have values there that we have not taught about. I mean, yeah, we know the angle of 90 degrees will always be 90, but what about the values inside, you know? How do we figure out those values? Well, this is where SOHCAHTOA comes to the rescue. Yes, it really does. So let me show you guys an example of how you can use these ratios, as they call it, to find a typical angle on the inside of your triangle. So let's just say in this triangle I've drawn to the side, we have been given the value of the opposite as, let's just say 6. Let's call that 6. And I'm not going to put any units in for today. And what about the adjacent? Let's just say the adjacent had a length of 8 with no units involved. How would we go about finding the angle theta? Now, if you guys looked at my last video, one of the first things that might be highlighted to you is that, yes, you can find the value of the hypotenuse using Pythagoras' theorem, because you do have 2 out of the 3 sides of the triangle, and that's cool. You can go ahead and do that. But this question is not asking us to find the hypotenuse, are they? They're asking us to find an angle. Pythagoras' theorem does not have anything to do with angles. So no matter how hard you try and you use Pythagoras' theorem for a question, you'll never be able to find an angle. So we have to resort to SOHCAHTOA. So we have 3 ratios. How do we figure out which one to use? Well, I have a method. I think a lot of people have different methods, but I'll show you mine. So I'm going to we are going to find the theta at the bottom corner, and I'm going to show you guys my method. So we have 3 trig ratios there, and you have to think, I don't know which one to choose. Well, the secret lies in what values you have actually been given. In our triangle, we have 6, and we know that 6 was the length of the opposite, which is O. So what you want to do is you want to tick off throughout each of your 3 ratios. You want to tick wherever you see that O, showing that you have the value for the opposite. Then in our triangle, we also have 8, and 8 is the length of your adjacent. Remember, that was A. So you want to go to each of your 3 ratios and you want to tick where you have that letter A. And we can see it up top here as well. Beautiful. So if you notice, 1 out of the 3 of our trig ratios actually has 2 ticks present, and that's TOA. And that's how you figure out which ratio is the correct one to apply for your question. The ratio that has 2 ticks for your sides that you have the values for would be the one to use. So we would not be able to use CA because you do not have sufficient values nor SOAP. I was going to say sine theta. So, okay, cool. I understand. So we use TOA, but I don't know how to use TOA. Well, I'll help you guys. So we know that, let me shift to the side here. We know that TOA stands for the ratio of the opposite to the adjacent. So let's write that down. So we are using tan theta, which is what TOA stands for, to be equal to the opposite over your adjacent. Okay, and our green ticks represent that we actually had those numerical values. So what we're going to do is perform a substitution. So going back to our question, we remember that the opposite was 6 and our adjacent had a value of 8. So that brings us down to the fact that tan theta is equal to 6 on 8 or 3/4. You could reduce it if you like. And we're almost there, guys. We're almost at the finish line. We're not fishing, we're almost at the finish line. Okay, so whenever you use these formulas of SOHCAHTOA, TOA, you're going to end up with a situation that looks like this. You're going to have either sine, cos, or tan theta being equal to some sort of fraction. And to find theta, what you need to do is to simply find something called the inverse. So if your function is tan, then you'll find tan inverse, and it's written as a power of -1, but it's not really the power of -1. It's just a notation. And I think I'll highlight for you guys that this is read as tan inverse. So if you're taking notes into a notebook, it might be wise to highlight this so that if you ever have to read an out loud in class to your teacher, you do not say that tan is to the power of -1. That's called tan inverse, kids. All right, so let's continue. So what we did was we took this tan, we took it across to the right-hand side, and it became tan inverse. And that 6 on 8 that was already there still remains there, but we want to use some nice pretty brackets. And we want to write it like this. So this is read as theta is equal to tan inverse of 6 upon 3. And 6 upon 8, wow. 8 does not look like 3, but anywho's. So last step, we need to go to a calculator. Now, if you're trying to pull up the function of tan inverse in your calculator, you can press the second function button. Looks like second function, and you can follow it up with the tan button. And if you look on screen, after you press these two tabs, you should notice that your screen has this. Then make sure that when you're doing questions like these, you want to use your brackets. So use your brackets, then you want to type in 6. And because it's a fraction, 6 over 8, you want to use your ABC button. You look for it, it looks like this, and then follow it up with an 8. And then you press your equal sign, and you simply make sure, of course, when you're doing that question, make sure that your calculator is set to degree mode. Make sure you are seeing a DEG written at the top somewhere in your calculator. And if you are correct, you should get a value of 36.9 degrees, correct to 1 decimal place. Of course, the question would specify how many decimal places they want their answer correct to. If not, make sure you state it in brackets to the side. So this is how you would use SOHCAHTOA to calculate. Okay, guys, so we're gonna look at another example where we'll be using a different trig ratio. Okay, So what I want to do is I want to try to change stuff up just a bit. Okay, so how about we have, let's just say we have this is 12 meters, and we have, let's just say this is 6 meters here, and they are asking us to find the value of theta. Okay. Now, in this question, of course, you can find the value of the missing side using Pythagoras' theorem, but that's not the lesson for today. Okay, guys, so we want to find theta. Now, to find theta, you cannot use Pythagoras' theorem. You must use one of your trig ratios. You must use one of so, oka, or toa. So how do we figure it out again? Well, you need to identify what sides you do have. So identifying this information, let's see, our right angle is located opposite this side, so that must mean we have the hypotenuse. So let's take that off. So we have the hypotenuse. So clearly you can tell we won't be using TOA at all. Then let's see, we have our angle theta here, so therefore the side opposite is called the opposite. So we'll take that off in our ratios. Now, the winner is the one that has 2 ticks. Kind of like when you send a WhatsApp message and it finally goes through. It's like, oh, yes, finally, you know. You can think of it like that. WhatsApp 2 ticks. That's the angle you pick. Okay, so we are going to use a so. Now, what does so break down into again? Well, S stands for sine theta, is equal to O stands for opposite, and H stands for your hypotenuse. You can write caps or common, it doesn't matter. Now we'll start substituting values. So we have sine theta is what you want to find. We have our opposite being 6 and our hypotenuse being 12. We're almost there, guys. Just one more final step. So last step, trying to shift my screen up here, and there we go. Just a bit of technical difficulties. All right, so theta will simply be given by, now last time we carried across tan to become tan inverse. It's the same thing. You'll get sine inverse, and remember to write your fraction in brackets. And then all you need to do is insert in your calculator the second function Merton sine, open brackets, 6 ABC 12, close brackets, equal sign, and you should get a value of 30 degrees. A lot of students, especially AdMath students, would know this value off by heart. So there you have it. That's how you would use the SOHCAHTOA, all of your different types of trig ratios to find the angle within a right angled triangle. So guys, if you want to see more questions like these, if you want to see a full worksheet on using SOHCAHTOA only, be sure to leave a comment down below. Be specific in what you would like to see more of, and I'll be happy to do a full tutorial question with you guys. Take care. See you soon. Bye.